A thin insulating rod is hinged about one of its end. It can rotate on a smooth horizontal surface and horizontal plane. The charge density on the rod is defined as, for half of the length, the charge density will be lambda1 ax square. You see this. For remaining half of the length, the charge density is given by minus b x to the power of n. What do you mean by negative sign here? Negatively charged. The first half is positively charged and the second half is negatively charged. Then we do have uniform electric field directed here. Plane and perpendicular rod is switched on. Find the values of B and N if the rod has to remain stationary. Okay, now what is the method? I'll assume a small element at a distance x from the inch. Okay, this is what? The inch. Got it? There's an inch. Once again, I'll write it. Okay, there's an inch. Now, what is the torque due to that one? D tau, it should be anti-counterclockwise. Torque on the positive charge on the rod is what we are defining. So that should be equal to dF1 into x. What is dF1? E into dQ1. What is further dQ1? Lambda1 into dx. What is lambda1? Given data, ax square dx. So till where the positive charge is present from x equal to 0 to x equal to L by 2. So the limits are 0 to L by 2. Integrating, solving, we'll get the torque. How is this torque? Counterclockwise. We know the force is upward and the x is horizontal. So the torque about 0.2 should be counterclockwise. This is R bar, this is F bar. How the torque should be? Torque should be counterclockwise. If this is R bar, this is F bar. So how the torque? If this is then how the torque? Torque should be clockwise. Now some rough idea I'm giving. Okay, now let's proceed in the similar way. So let me assume a small element of length dx. Then torque on this will be dF2 into x. Let it be still x only. I'll remove this so that. Please notice the limits. It's very important. I assumed a small element of length dx. This will be dF2. Let it be x only, the limit. So what is the charge here? Negative charge. This is a positive charge. So dF2 into x should be the limit. So it should be the torque. And how it will be? It will be clockwise. So what is dF2? E into dq. dq equal to lambda2 dx. Further, lambda2 is what? Given by this minus bx to the power of n. Only substitute magnitude. Already the sign we have taken care. Okay, then everything after integrating, so we'll end up with x to the power of n plus 2. The limit should be L by 2 to L, no? Because x equal to 0 to x equal to L by 2, x equal to L by 2 to capital L. Solving, I'll get the top 2. And for equilibrium of the rod, what we can assume? The net torque should be 0. So solving that, we'll end up with this answer. Then afterwards, is asking find the hinge force at the is asking to calculate this hinge force. So what is the method we have to do? The net positive force on the positive part of the rod, the net force acting on the negative part of the rod. I'll calculate these two forces by this formula. Then I'll substitute here. Then I'll calculate the hinge reaction will be in fact 0.